two formulas we want to review for 9-1, which is the circle, standard form of a circle. X minus h squared plus y minus k squared equals 1. Or sorry, equals a radius squared. Starting to get ahead of myself for today. And then the other, which is the parabola. And there were two formats, one where the vertex was at 0, 0, the origin, and the other where it wasn't. So I'm just going to do where it wasn't because you can use that for either. So if it was a vertical parabola, then it would be an x minus h squared equals 4p y minus k. And if it's a horizontal one, then it was y minus k squared equals 4p x minus h. So if the origin was the vertex or the vertex was at the origin, then my h's and k's would cancel out from that equation. Number 1 said find the equation in standard form of the equation of a circle with the given information. So the center is at 6, -3, and the point on the circle is -2, 4. And we said yesterday there's two ways to do these. One is distance formula, and then one is plugging in the h, k, x, y, finding r, and then plugging that back in. How many of you did the distance formula out of curiosity? And how many of you did the x, y, h, k? Okay, so I'm going to do that. So the center would have been h, k, and the point on the circle x, y, and I would plug it in. So x minus h squared plus y minus a -3 becomes +3 squared equals the radius squared. This is -8, +7, 64 plus 49. 113 is the radius squared. So if it had asked for the radius, I would write it as the square root of 113, but we're just plugging that back in, so I don't even have to square root it. I would do x minus my h, which was 6 squared, plus y minus my k, minus a -3 becomes +3, squared equals 113. Raise your hand if you got it right. Okay, good. Number 2, write the equation of the circle in standard form, then identify its center and the radius. So this time we're back to completing the square. We have to complete it twice. I said it yesterday, but I'll say it again. Complete the squares is definitely a skill you need to master. If you are still shaky on it, then look back. That's chapter 2. That's the beginning of chapter 2, because we're going to do some more even today with ellipses. It does not go away. So the first thing I'm going to do is group together my x's and my y's, and bump the 17 to the other side. Now this time there's something attached to both the x and the y. Yesterday we did it when we got to parabolas, but this is happening now. So I have to get rid of that. I either have to factor it out of the individual pairs, or what's another option I could do? Good. I can multiply the whole thing by 1/9 or divide by 9. I would only recommend that if everything on the left side is divisible by that same number. Otherwise, it gets really ugly. It does put a fraction on the right-hand side, but that fraction is going to come eventually anyway, so it's not a huge deal. But I would only recommend doing that if all of those things are divided by the same thing. We're going to get to one today in which they're not, so I'm going to walk through the process of how you would do it otherwise now. So I would take the 9 out of both of these, and I'd get x squared plus 6x. I'm going to leave that space because I'm going to fill it in. And I would take out the 9 here, y squared minus 4y. Leave this space. And then I want to complete the squares. So 6 divided by 2 is 3. 3 squared is 9. I'm going to add the 9 here. And typically I would add the 9 to the other side here. But because we took that 9 out, I have to accommodate for it. How do I do that? Good. So I'm going to multiply the 9 by the 9 that I would have on the outside, and this time I'm adding 81. Which means if I had taken out a negative, I'd be subtracting it instead of adding it. So pay attention to stuff like that. And then for this one, for the second one, -4. 4 divided by 2 is 2, square it, and I get 4. So I add the 4, and then again, I have to account for that 9. So 9 times 4 is 36. So these are 9 would go on the outside, perfect square, square root the first, square root the last, take the sign from the middle. 9 goes on the outside, square root the first, square root the last, take the sign from the middle. And then this is 117 minus 17, so that's 100. Standard form of a circle can't have anything in front of the parentheses, so I have to take now and divide everything by 9. So this is where it levels off. I'd end up with x plus 3 squared plus y minus 2 squared equals 100 over 9. So if you had divided by 9 in the beginning and got negative 17 over 9 on the right-hand side, then when you added, you would have had 81 over 9 and 36 over 9, and it would have ended up with 100 over 9 either way. So from here it says, identify the center and the radius. What's the center? Negative 3, positive 2, and the radius? Good. 10 over 3, square root both the top and the bottom. So this time it wanted the equation and the center and the radius. You can count on completing the square at least once on your quiz. So make sure you know how to do it.
When is the quiz again?
Monday. Yeah. All right, find the intercepts of the graph of the circle. So we talked about yesterday that finding the intercepts of a circle is the same way as finding everything else. If I want to find the x-intercepts, I'm going to plug 0 in for y. So I'd get x plus 5 squared plus negative 4 squared equals 25. X plus 5 squared plus 16 equals 25. X plus 5 squared equals 9. X plus 5 equals plus and minus the square root of 9, which is plus and minus 3. So I get negative 5 plus 3 and negative 5 minus 3, which is negative 2 and negative 8. So there are 2 x-intercepts. And then I want to repeat that process for the y-intercepts. This time I plug 0 in for x. So I'd get 5 squared plus y minus 4 squared equals 25. 25 plus y minus 4 squared equals 25. Y minus 4 squared equals 0. Plus or minus 0 is still 0. And y equals 4. And there are your intercepts. Questions on that one? Okay. And 4, write the standard form of the equation, vertex at 0, 0, focus at negative 2, 0. So now we've started to talk about parabolas. So yesterday I suggested giving yourself a visual. So if my vertex is at 0, 0 and my focus is at negative 2, 0, what direction is this parabola pointing? To the left, which means it is a y squared. And what's true about p? Negative. So the p-value comes from literally the distance between these. P would be 2. And then I already know the vertex is at 0, 0, so I can simply plug it in. It would be y squared equals 4p times x. So y squared equals 4 times negative 2 times x. Y squared equals negative 8x. We talked about it yesterday too, but what happens if I would ask you to find the directrix? How would I find it? So what's true about the distance from the vertex to the directrix? Good. So I'm going to go to the right p instead of the left, right? So there would be my directrix. It's a vertical line, which means it's in x equals, and it's a positive 2. So make sure that you, again, are comfortable enough with the directrix, the focus, and the vertex so that you'd be able to bounce back and forth between all that information. Number 5, find the vertex, focus, and directrix of the parabola and sketch its graph. So again, completing the square. As soon as you see that you have a repeated variable, 1 raised to the power of 2 and 1 not, you know you're going to complete the square. The good news is with a parabola, you only have to complete it once. So I'm going to bump the 4x to the other side. So I get y squared minus 4y. Leave that space because I'm going to fill it in. Equals 4x. Take the 4 divided by 2. It's 2 squared. It's 4. Add it here and add it here. So this is y minus 2 squared equals 4x plus 4. But I can't leave the 4 attached to the 4, which means I have to factor it out. So y minus 2 squared equals 4 times x plus 1. There's my standard equation. And then from there, what's this graph going to look like? If it's a y squared and a positive p, it's going to face the right, right? So the vertex comes from the opposite of x and the opposite of what follows y. So the vertex It's negative 1, 2. How do I find P? Good. So this, whatever's in front of that non-squared term, right? So 4 would equal 4P. Divide both sides by 4, and P is 1. That means that if my vertex, so let me make this a little bit more accurate. If my vertex is at negative 1, 2, and I know this is facing to the right, that the focus is 1 unit to the right of it, which puts it at 0, 2. And the directrix is 1 unit to the left of it, and it's a vertical line, which is an x equals, and it would be a negative 2. So for this, we need the vertex, the focus, the directrix, and the graph. Questions on that one? All right, and then 6, find the standard form of the equation of the parabola with a vertex of 5, 2 and a focus of 3, 2. So use that information, 1, 2, 3, 4, 5, 1, 2, that's my vertex. Focus, 1, 2, 3, 2, which means this is a parabola pointing which direction? Left, which means y is squared, but P is negative. P is, again, the distance from vertex to focus, which in this case, God bless you, is 2. So I would get y minus k squared equals 4px minus h, because the center is, or the vertex is no longer on the origin. Y minus 2 squared equals 4 times negative 2 minus 5. So y minus 2 squared, no, not when they call you, equals negative 8x minus 5. Questions on any of that? Mm-hmm.
For number 5,
Mm-hmm.
like I don't get how you got x plus 1 on the right side. For the 4.
So once you move this, so you're here, right? You've got this.
Yeah.
You can't have anything physically attached to the y or the x, which means whatever's there has to get factored out. So it just happened that they were 4 in both spots. But if it was 4x plus 12, I'd still have to take out a 4, whatever's attached to that x. And if it was switched, if the x was squared on the left and the y was on the right, you do the same thing. Anything that's attached to that variable should get pulled out in front of parentheses.
And you can't have anything in front of...
You can't have anything over here. Yep, no, so if there was something there, I would actually divide by it to put it on the other side. It would change whatever that 4p value is. Mm-hmm. So quiz-wise, which is Monday, you're going to see, like, I think there's 2 problems from circles, 2 problems from parabolas, and then we're going to get into ellipses today, 2 problems from ellipses. But obviously they have multiple components to them, so they have different weights. But you want to know how to work both ways. If I give you the information about the parabola, could you give me the equation? And if I gave you the equation, could you get it into standard form and then give me the information about it? So you want to make, and could you graph them? Same for a circle. So 9-2 is ellipses. Ellipses are like circles, but they're flattened, so they're like an oval. Okay, there's 2 different types, horizontal and vertical. So they are the third of the 4 conics we're going to talk about. So an ellipse is the set of all points x, y in a plane, the sum of whose distance from 2 distinct fixed points, which are called the foci, is constant. So you have 2 focuses. The plural of focuses would be foci. You're going to have 2 vertices, and you're going to have 2 co-vertices. So there's 6 different types of points as you move around your circle. Obviously, it's symmetric. So you're going right and left the same amount from your center. You're going up and down the same amount from your center. This is an example of a horizontal one because it's wider than it is tall, but we're going to talk about both of them. Major and minor axes. So the line through the foci intersects the ellipse at 2 points called the vertices. So the line that has the foci also has the vertices. That's going to be your major axis. And its midpoint is the center of the ellipse. And then the chord perpendicular to the major axis is called the minor axis. Major is bigger, minor is smaller. So the foci and the vertex and the vertices lie along the major axis. And then the other two endpoints, these are called co-vertices. So you've got the vertex. The foci would be along this line, which is your major axis, and then the co-vertices lie along the shorter line, which is your minor axis. Standard form of an ellipse. So if you just look at it, the standard form of the ellipse is centered, if it's centered at 0, 0, then it depends on whether the major axis is horizontal or vertical. If it's horizontal, and you'll know this because the larger denominator goes under the x if it's horizontal, and the larger denominator goes under the y if it's vertical. If it's horizontal, then obviously it is wider than it is tall. Again, the foci and the vertices lie along that major axis, and the co-vertices lie along the minor axis. If it's vertical, then it's taller than it is wide, and the foci and the vertices lie along the vertical axis, and the co-vertices lie along the horizontal, which is the minor axis. Again, the larger denominator determines which one it is. If the larger denominator is under the x, then it's horizontal. If the larger denominator is under the y, then it's vertical. These are the equations. So x squared, this would be if there is a center at 0, 0. X squared over a squared plus y squared over b squared equals 1 is your horizontal. And honestly, the order here doesn't usually change. It usually still stays as x squared over b squared plus y squared over a squared. It's a plus, so the sign doesn't matter. I mean, the order doesn't matter. What does matter is which denominator gets the bigger number. So the a is the bigger number, which means the a squared is going to be the bigger number. If the a, or the larger denominator, is under the x, then it's horizontal. So if the a is under the x, it's horizontal. And if the a is under the y, then it's vertical. But the order of the x and y do not matter. So it matters when we get into hyperbolas. It does not matter for an ellipse because the plus doesn't matter, right? You can switch around a plus and it doesn't change. So the distance from the center to the vertices is your a. So because I'm at the middle, if I were to draw an ellipse, then I would find the center. So the center's here. And let's say it's a horizontal one, so it's wider than it is tall. Then the distance from the center to the vertices is your a. The distance from the center to your foci is your c. And the distance from the center to your co-vertices is b. So there's 3 values happening there, and the relationship between them is c squared equals a squared minus b squared. So it looks similar to Pythagorean theorem, except the sign is different, right? C squared equals a squared minus b squared. A squared is going to be bigger, so it always comes first. And a is the distance from the center to the vertices, which are along the major axis. B is from the center to the co-vertices, which is on the minor axis. And C is center to foci. Think foci has a C in it, okay? And then the other piece of information that's on here is that the length of the major axis is 2a, which should make sense. If I'm going from center to the right a and center to the left a, then that major axis should be 2 times a. And the length of the minor axis is 2b. I'm either going from the center to the right b, or center to the left b, or center up b and center down b. So that's the minor axis, and that should be 2b. So you could spend time trying to memorize that whole chart, but if you could just understand why to apply it, it's so much easier than trying to figure it out, because as soon as we shift the vertex, shift the center, the whole thing gets shifted. So in my opinion, it's easier to just like we did yesterday with parabolas, kind of start mapping them out, get that physical connection between it, and then it makes your life easier. The things you have to memorize are like c squared equals a squared plus minus b squared. And then I would want to know major axis is 2a and minor axis is 2b. The rest of it is application. So if you are one of those people that waits for a review to try to figure this nonsense out and you copy somebody else's homework, maybe you want to change your game plan for the next week. You might want to change it for the rest of your life, but also really for the next week. Yeah. All right, so if I shift my center, everything gets shifted. So again, instead of memorizing this whole chart, I would just try to figure out what does that do if I shift it. If I had a center that wasn't at 0, 0, let's say it's at 2, 1, and I know it's a major axis that's vertical, then I'm going to go up my A and down my A, up my C and down my C to get the foci, and right the B and left the B, and that's going to get me my ellipse. So wherever the center is, you want to establish where's your center, obviously, at some point, based on the information they'll give you, which we'll do a couple examples. You want to know, is it a vertical or is it a horizontal? If it's vertical, then I know I'm going from my center up A and down A to get the vertices, up C and down C to get the foci, and right B and left B to get my covertices. If it's horizontal, so let's just say it's horizontal and my center is somewhere over here, then I know I'm going right A and left A to get my vertices. I'm going right C and left C to get my foci, and I'm going up B and down B to get my co-vertices. So the A, vertices, B, co-vertices, C, foci. Distance between center to them. And I'm either going right and left if it's horizontal for the vertices and for the foci, or I'm going up and down if it's vertical. Does that make sense? Because I think that's a whole lot easier than memorizing a chart. Like memorizing a chart and trying to figure out how to use it is a lot harder than just understanding the relationship between them. And then you will get given enough information so that you know at least 2 of those 3, and you'll use c squared equals a squared minus b squared to find the missing piece of the information. It's just how they deliver the information is going to be different every time. So this time it says find the standard form of the equation of ellipse having a foci at 0, 1 and 4, 1 and a major axis length of 6. So start with what you're given. Give yourself a visual because it will be easier. So foci at 0, 1 and 4, 1. 0, 1, 1, 2, 3, 4, 1. These are your foci. Just from that piece of information, could you tell me, is this vertical or is this horizontal? It's horizontal, right? Foci lie along the major axis. This means the major axis has to be a horizontal line. This makes this a horizontal ellipse, which means which letter gets the A? The X. So it's going to be X squared, maybe plus or minus something over A squared plus Y squared, maybe plus or minus something over B squared equals 1. So I already know that part. Now I can figure out my center. Where is that center in relationship to the 2 foci? Directly in the middle. So I can either use the midpoint formula, or if I've graphed it, you could probably spot it, right? What would be the center here? Yep, well, 2, right? Because it's 0 to 4. So it'd be 2, 1. Now I've got my h and my k. So now I'm at x minus 2 squared plus y minus 1 squared equals 1. What can I find from the distance from the center to the foci? What value is that? C, what is it? Count from the center to the foci. Center to foci. What is it? 2. So I already know C. C is 2. That's the one that doesn't go in the formula, so it doesn't help me fill it in, but it does help me find what I need. So I have the C. I need A and B. I don't have enough yet to plug it into C squared equals A squared minus B squared. But what other piece of information did they give you that we haven't used? The major axis. So if the major axis is 6, what did we say the major axis equals? 2A. So A is 3. Now I've got C and I've got A, and I can find B because C squared equals A squared minus B squared. So 2 squared, 3 squared minus B squared. So if I square root the B, I would get square root 5, right? But when I plug it back into the equation, what do I do to B? I square it. So if I want to know exactly what it is to graph it, then I would go and I would actually square root B, or square root 5, so I get B. But to plug it in, I don't even need to square root it. I can just leave it squared. So we said the X got the A because it's on the major axis, which means A squared goes in the bottom here, which would be 9. And we said the B would go with the Y because that's the minor axis, and B squared is 5. And there's your equation. I didn't have to graph it, but if you wanted to, from your center, you would go out 3 in both directions for your A. Those would be your vertices. And root 5 would be a little bit bigger than 2, so I'd go up a little bit higher than 2, down a little bit lower than 2, and I'd have my ellipse. So again, sometimes they could give you the minor axis and the foci, so you'd have C and B. They could give you the foci and the vertices, so you'd have C and A. They could give you the co-vertices and the vertices, and you've got your A and B. That's the easiest case, which is probably not going to happen. They could give you the foci, what did I going to say? The foci and the co-vertices, and that's going to give you your C and your B. So you'll always have the 2 pieces of information. It's just how they deliver it that's going to be different. All right, we'll do one more and then we'll stop for today. So sketch the ellipse given by following the equation, identify the center and the vertices. So now we have switched. Now we have the equation and we have to find the center and the vertices. What do we notice about this equation? Nora. There's no denominator, which there's obviously should be 1, right? Because they can't both be 1. Something's wrong there. But if you look back on your standard equations, what do each of them equal? 1, which means that's the first thing you have to do, okay? Well, not necessarily the first thing. First thing would be figure out if you have to complete the square. Luckily, we don't have to do that yet, but just wait. We'll do that tomorrow. So I would know that if I have an x squared and an x, or a y squared and a y, that I have to be completing the square. This one's already a perfect square. It's just not equal to 1. So I'm going to divide everything by 36. So I get 4x squared over 36 plus y squared over 36 equals 1. So x squared over 9 plus y squared over 36 equals 1. Is this vertical or horizontal? Vertical, because the larger number is under the y, right? What is a squared? 36, which means a is 6. What is b squared? 9, which means b is 3. And what is your center? 0, 0. There's nothing adding or subtracting from the x or the y. That's where the center would lie.
So this one is vertical?
This one's vertical because the larger number's underneath the y. So then I just have to plot what's left. Center's at 0, 0. It's vertical, so I'm going up the 6, which is the a, and down the 6, and right the 3, and left the 3. So my center 0, 0. My vertices are 0, 6, 0, negative 6. And my co-vertices, if it asks for it, which it doesn't, is negative 3, 0, and 3, 0. And then if it asks for the foci, I'd have to do c squared equals a squared minus b squared and go up and down that value. Questions? All right, so we grouped the x's together, we grouped the y's together, bumped the constant to the other side. I can complete the square on the x is fine, but the y has something attached to it. So remember, your y squared has to be a 1y squared. I take out that 4. So yesterday we talked about sometimes you can divide everything by the same number and it's easy to do it. This is a case in which it's not. I can't go straight across my entire equation and divide by 4, otherwise I'm dealing with fractions far before I need to. Okay, so keep in mind that sometimes it's going to be easier to group it and take it out. So I took out the 4. When I completed the square on the x's, 6 divided by 2 was 3. 3 squared is 9. I added it to the left and to the right. When I complete the square on the y, negative 2, I just do 2 divided by 2, which is 1 squared. It's 1. Normally I'd add 1 to the other side, but because we took the 4 out, I have to multiply it by 4 first and then add it to the other side. So again, keep in mind if I had taken out a negative 4, because that's going to happen when we get to hyperbolus, if I had taken out a negative 4, I'd have to multiply by negative 4, which would mean I'm subtracting it from the other side. Whatever you take out has to get multiplied by what you add to the other side. So now I'm at x plus 3 squared plus 4 times y minus 1 squared equals 4. So I've completed the square, right? But that's not standard form yet because why? Good. It's got to be equal to 1, so I got to divide everything by 4. So I'd get x plus 3 squared over 4. Plus the 4's cancel, so y minus 1 squared equals 1. What's the denominator on the y? 1. So even though it's not there, it's not 0, it's 1. Yep.
So when you go to put this into standard form, although you divided by the 4 stays on the outside as well?
Yeah, it's still there. So when you go to complete the square, that number's still always there. Only if you divide every term on your entire equation, both left and right, does it completely go away. You're taking it out, but it's still there. You factored it out. It doesn't go away unless you divide everything by it.
But that still makes your first term 1.
Inside the parentheses. So you're completing what's inside the parentheses. Yep. Okay, so what kind of ellipse is this? Horizontal, because the larger denominator is under the x, right? Which means a squared is 4, making a 2. B squared is 1, making b 1. And this does ask for the foci, so I'm going to take it the step further and find c. The relationship of c squared to a squared and b squared is c squared equals a squared minus b squared. So c squared would equal 4 minus 1. C squared equals 3. C equals the square root of 3. So I've got all the letters I need. Now I've got to apply them. Yep. So if you wanted to graph it first, obviously you also need the center. And the center would be what? Good. Negative 3. Positive 1. So if I start by plotting that point, and we said this is horizontal. So I'm going right and left. My A, which we said A was what? 2. So I'm going to the right 2 and left 2. And I just found my vertices. which you can either get from the graph, -5, 1, and -1, 1, or take your center and add and subtract the a from your x values. Think about it's horizontal, so you're adjusting your x values. So because my center was -3, 1, I would take -3 and subtract 2 from it to get -5, add 2 to it to get -1. And then we said B was 1. So now co-vertices, because this is horizontal, would go up and down B. And we just found our co-vertices. Which again, I can get from the graph, -3, 2, and -3, 0. Or I could go look at my center, and because we're moving up and down on this one, I'd be adjusting the y, so I'd be adding 1 to the y, -3, and then 1 plus 1 is 2, and then subtracting 1 from the y, the -3 stays, 1 minus 1 is 0. So I can already draw my outside of my ellipse. The only thing left is the foci. Which axis is the foci on? On the x-axis, the horizontal. So I'm changing the x. I'm adding and subtracting the foci, or the c, sorry, from the x. So this time it's not a whole number, which means I'm going to write it as -3 minus √3, 1, and -3 plus √3, 1. But on my graph, I'm going to approximate √3 to be like maybe 1.8, something like that. So I would go -3. I would go 1.8 out from either point on your x. So 1.8 might be here, and that would be your foci. The foci comes from the c. So c we found was √3, right? So from my center, because it's horizontal, I'm going left and right √3, which means I'm adjusting the x coordinate, right? So I'm either subtracting it from the x and then adding it to the x. And then from the graph, you're literally just going from your center and going left and right, whatever the value of c is, which we approximate. It's like 1.7, 1.8. Questions on this? So if you want to star a question that is worth 30 points on your quiz, this is it. Okay? Because there's multiple parts to it. So it's got your complete the square portion to it. It's got the graph. It's got the finding the center, the foci, the vertices, the co-vertices. And then I'm going to add one more thing to it, and I'll tell you when we get there. But this one and the next one are both like that. All right, so tell me all the stuff you know about. Tell me everything you know about this equation or this graph just by looking at it. It's vertical because the larger one's underneath, right? What else? What can you pull out of that equation? So I know it's vertical. A squared is the bigger one, right? So a squared is 16, making a 4. B squared is 4, making B 2. Before I even have to do any other math, what else do you get from your equation just by looking at it? The center. Center is 1, -2. And then the only other thing I need to get out of this is the foci, right? So c squared equals a squared, which is 16, minus b squared, which is 4. C squared is 12, making c the square root of 12, which on the graph I'll approximate to be in between square root 9 and square root 16. So this is approximately, let's just say 3.5. And in my actual answer for my foci, I'll reduce that to 2 root 3. So now you've got options. Go to the graph first or figure out your points. It's totally whatever you're comfortable with. If you're the visual person, I would say go to the graph. So 1, -2 is here. We said that this was vertical and that A is 4 and B is 2. So I'm going up and down the A this time. Right and left the B. And up and down C, which we said is like 3.5. So 1, 2, 3.5, 1, 2, 3.5. And then I've got to list all the things they asked for, which was the center. We have 1, -2 here. The vertices, which are on the y-axis or the vertical axis because this is a vertical one. So we went up 4 and down 4 from our center, which means the x is staying the same, but the y is getting added and subtracted 4. So this becomes 1, 2, and 1, -6. The co-vertices would have been along the horizontal. So this time the x is changing. So I went right and left 2, subtract 2 from that 1. I get -1, -2, add 2 to it, and I get 3, -2. And then the last thing is the foci. And that comes again vertical. So I went from -2, from 1, -2, and I'm adding and subtracting 2 root 3. So you can either separate it out. I can do -2 plus 2 root 3, -2 minus 2 root 3, or you can write it as plus and minus, as long as it's graphed. Obviously, both of them are graphed. It doesn't matter how you write that. So again, in a second, I'm going to add one more component to this question. However, up to this point, this is a good view of what the biggest question is like on your quiz. It's going to ask you to find the equation. So that's one component. Find the center, find the vertices, the co-vertices, the foci, and then graph it. All those different components, which means you're going to be super careful on your complete the square. Should you get the complete the square part wrong, it continues wrong. I'm not going to take off all of the credit. Like, I won't totally dock you, but you're not going to be able to get full credit on the rest of the questions based on an incorrect complete the square. So you want to make sure you're comfortable with it. Questions? Okay, the last part is called eccentricity. And basically what this causes is how oval or like how stretched or rounded your ellipse is. Okay, the eccentricity of an ellipse is found by doing C over A. So it's like 10 seconds. You've already found C, you've already found A. You literally just have to reduce that ratio. And it's always going to be between 0 and 1 because C is always smaller than A. It will always be between 0 and 1. It's never going to be negative. And the bigger or the number, so the closer to 1 it is, the more stretched your oval is. The closer to 0 is, the more rounded it gets. So like a circle would be at 0. The closer it is to 0 would be the, like the rounder the object is. And as we pull it out, whether it's horizontal or vertical, that's what makes it closer to 1. So this would be an example, obviously. If the C was really close, if C over A is really close to 0, it's more rounded like that, almost circular shape. And then on the one on the right where it would be closer to 1, it's going to be more stretched out. So if I look at the one that we did already, if I find just C, which we already did, we found C and we have A. So I'm going to say C was equal to 2 root 3. Wait, where'd that word go? Oh, I put it all the way over here. 2 root 3. So sorry, E equals C over A, which would be 2 root 3 over A, which was 4. This reduces to root 3 over 2, which we said root 3 is like a 1.7, 1.8-ish. So if that was 1.8 over 2, then this is 0.9. which is pretty close to 1, which is why this is more of a flattened and stretched out ellipse. So the last component on this type of question will add what is the eccentricity. And you can kind of use it just to make sure that your shape is confirmed. Again, if it's closer to the center, if it's more round, then your eccentricity should be closer to 0. If it's stretched out, flattened a little bit more like that oval shape, then it should be closer to 1. So quiz review, you want to go over your circles, you want to go over your parabolas. The warm-up from yesterday is a good review on that stuff. Obviously the homework's a good review. And then add to it the ellipses. I will post the answer to the evens, just the answers themselves to the evens on the ellipses, because I won't see, especially seniors, I won't see you again before Monday. And then if you've got questions on Monday when we come in, we'll have time at the beginning of class to go over it. Just don't wait till Sunday night to go over all this stuff.
What's it?